Hi, everybody. My name is Bindu Reddy, and I am a general manager at AWS AI. So welcome to AWS, I guess, AWS Loft, and welcome to Amazon Forecast Overview. So I'd like to make this slightly informal, so just feel free to stop me and ask questions if you have any, and and I'll be happy to answer them. Make sense? Also, I would like to get kind of an understanding of familiarity of Amazon Forecast with the audience. How many of you have even heard of it? Okay, not many. That's good. So this is going to be a little bit of an overview of the service. We launched the service at re:Invent this November, and right now it is in private preview. And if after this presentation you're into checking it out or what have you, you can go to Amazon Forecast on your AWS console and request preview access. But I'll get started. Clicker doesn't seem to work, but OK. So Amazon Forecast deals with the science of time series forecasting, right? It's not something which is that difficult to kind of grok. It's something where we basically take past time series data and try to predict future points. It's probably something which all of you have probably done sometime in your professional career, or even in even before that. And when you go and use Excel and you basically draw a trend line on a particular graph and kind of look at future points to a particular time series, in some sense, you're forecasting. So you're predicting future points based on the past history. However, it turns out that the science of time series forecasting is a really interesting one across multiple domains. And it's also exceptionally hard to do. Because if you could actually forecast everything, you could predict pretty much anything, right? Imagine if you could do time series forecasting on stocks. We would know exactly what the price of any particular stock would be on any particular day, and we would all be rich. Similarly, if you could do time series forecasting on weather or what have you, you're literally predicting the future. So it's a very difficult problem, but it's also a very important problem. And as you can imagine, it is applicable across many different domains in enterprises and organizations. Now, this is something which really matters to us being Amazon.com, for obvious reasons. We have a huge supply chain of millions and billions, actually, technically, billions of products which are available on our website, right? And what we do is anytime any of you click something on Amazon.com and you say you want to buy it, there is something which gets triggered in the back end where we figure out which fulfillment center is going to fulfill that product. We're going to actually go and package that product and ship it. Now, all of this was not going to be possible if we didn't have really good forecasting. We really need to forecast exactly how much of each product we need to stock at any fulfillment center. Imagine if we stocked too little. So every time people clicked, we wouldn't have that product, and we would run out of stock, and we would have a bad experience. But imagine if we stocked too much. Imagine if we had 10x the amount of product, let's say some TV, some expensive $20,000 TVs. We had 10x the amount of inventory. It would be sitting there in our fulfillment centers, not clearing and wasting space for us. So we really have to be able to figure this out being as accurate as possible, so that we can make sure that most of our product is getting cleared on time, but also our fulfillment center space is not being wasted. So it's a very big use case for us, very big use case for pretty much any retailer, any e-commerce vendor, any manufacturer, right? Because they all want to optimize inventory space, they all optimize fulfillment center space, and also predict demand. Because as a manufacturer, you might want to be predicting future demand for any of the things that you make, so that you can figure out how much raw materials to buy, and how much you want to manufacture of a particular product. Another use case for workforce demand. Again, with Amazon, we need to actually make sure that our fulfillment centers have the right amount of workforce at any particular time. Obviously, during Prime Day or during Christmas, we have a huge spike in demand. So we'll probably need to get more fulfillment center workers during those times. And if we don't actually predict exactly how many people we need at a particular location, we're basically, again, not going to fulfill our customers' orders, and we'll end up with a bad customer experience. So something, again, which is really important for us to do right. Financial metrics, This is really common. Every company, every large organization, and even a small organization wants to predict or forecast their revenue, their cash flow, their growth, and whatnot. This gets especially interesting when you have a large organization with lots of business units, lots of geographic locations. You want to or lots of products, right? You want to really slice and dice that revenue or cash flow, what have you, per business unit, per location, per per product type. Another example, inventory planning is something I touched on really a little bit before. You want to be, that's actually a picture of an actual Amazon fulfillment center, and you want to be able to plan exactly how much raw material you want to get at a particular point in time. Since I've made this slide, I've heard of many, many more examples where time series forecasting has been important. There's been media companies who wanted to predict traffic, web traffic to their sites. Also media companies who want to predict advertising demand. I just talked to a networking company who wants to predict network traffic on each of their routers. So it's a very universal problem. If you're an organization doing anything, you want to be able to see how the future looks like so you can plan for it. Obviously, the problem with forecasting is accuracy, right? The more accurate you are, the better off you are. Forecasts which aren't accurate really aren't that useful. And the real important message to take away from this slide is that even a small change in accuracy actually results in a huge improvement to the bottom line. Right? So if you're looking for, hey, I need to go to my organization and come up with a machine learning project or a model which will actually change the bottom line significantly, forecasting is your, use case to pick, because it really does make a difference if you can forecast and plan better versus not. Now, given that this is such an important use case, obviously there are multiple methods and there are multiple algorithms which are available today. There are also multiple products which are available today, some of which are very expensive, but they're available in the market. But most of them use traditional methods. These traditional methods are either based on statistics, some of them use classical machine learning models, and there are some shortcomings to these methods. A lot of them don't, some of them do, but a lot of them don't handle seasonality really well. So what that means is the demand for a product can go up and down based on a particular season, a month, and you won't be able to predict that really well if your model can't handle seasonality. Doesn't consider metadata. So almost every statistical method won't take into account the type of time series you're forecasting. Let's take the example of this networking company. They want to be able to predict at any point in time the traffic that they'll get through all of their switches and routers, right? If you used a statistical method for that, you're not going to be able to take into account the type of networking router or switch, and so you'll have to just use historical time series data. You can't use other data, like other data around the attributes of what you're predicting. Similar to that, if you take, more kind of like a mundane example like product demand, you have to only look at historical data to be able to forecast past future data points if you are if you're using a statistical algorithm. However, if you use something more sophisticated, you can actually look at the different attributes of the product, like color, genre, brand, and so on. So if you can look at all of these different types of attributes, you can get more from your data than if you didn't. So today's algorithms don't consider metadata. Most of them don't consider external factors. So if you think about things like holidays, which will have an impact on your demand or impact on your prediction, and if you can't consider it, you're going to get your forecast wrong. Similarly, there are a lot of promotions people run. They could be running a Facebook promotion or a promotion at an ad company where they're driving traffic to a particular e-commerce site. And when you are running a promotion, obviously your demand will spike, and you want to be able to predict that. Because if you don't predict that, you can't plan for it. Finally, traditional methods really only work for time series which have historical data. The definition of a traditional method is look at the historical data and predict future points. So what happens when you have new items? What happens if you have new switches and routers? Or when if you're a fashion company and if you started a new line of, clothing, how would you predict demand for that? That becomes really challenging. Now, as you can imagine, all of these problems are problems which we faced quite severely at Amazon, and therefore have worked on, pretty extensively. So at Amazon, we have a very, very big legacy of forecasting. We have one of the biggest forecasting groups there is. I would say we have over 1,000 people working across the company on this problem, and we've pretty much revved a whole bunch of different methods. And what we have found is, especially when it comes to kind of multiple time series, when you have a lot of data and you want to be able to predict future points in that data, deep learning really increases forecast accuracy. So this particular example I'm giving you is based on an algorithm called MQRNN, which is a recurrent neural network-based algorithm, which Amazon has developed. We've written a paper about it. In fact, we've written quite a few papers around forecasting, so you can look it up. We have observed that using deep learning tends to increase forecast accuracy compared to some of the other methods. So in this graph, I show you we have forecast metrics across 60,000 different products. 60,000, I believe, soft lines, which is basically fashion category inside of Amazon. And these are the forecasts of 4 products from that, from that particular run. And what you're seeing here, and what I want you to look at is graph 3 and graph 4, right? Graph 3 basically shows you that, we actually can get a forecast even if you didn't have any prior history. So, and graph 4 shows you that we're also able to predict spikes in the forecast. So whenever there's a big promotion, there is that thing which is like going right up. That's when there is a promotion or what have you, the forecast, the forecast actually picks up on that and also predicts a spike. So these are examples where we've published them and where we've tested it with our own data. So given that we've had so much experience and so much success in some ways using forecasting, at AWS, we were like, look, what is it that we can do to give to our AWS customers, where we can package the technology we've developed over the last 20 years or so and make that available to our customers? And we said, why not come up with an automated forecasting platform? So we were excited to build and launch Amazon Forecast. Amazon Forecast draws from 20 years of experience in forecasting at Amazon. So this is a lot of the algorithms that are packaged inside of Amazon Forecast are part of that experience, are part of that technology that we've developed over the last few years. During our beta testing and during testing with a bunch of public data sets, we've noticed that our accuracy on some of the models, some of the algorithms we have on Amazon Forecast are about 50% better or more accurate than traditional methods. So we had a private beta phase. We looked at a whole bunch of public data sets. We also worked with some private beta customers, and now we're working with our public preview customers. And we're seeing consistent improvements on accuracy over traditional methods. Now, not all data sets work well with deep learning. There are some data sets which actually will do better on some of the classical and traditional methods. So because of that, what we've done is, as part of the Amazon Forecast, we've actually packaged 8 different types of algorithms, 5 of which are deep learning, but 3 of which are more like conventional statistical algorithms, ARIMA, ETS, and PROFIT. And the reason we have that as part of this service is that we want you to benchmark your data set across these different algorithms. Pick the right tool or pick the right algorithm for your particular data set. So the service comes packaged with an array of different types of algorithms, and we're also planning to add more over the next few months. So what does Amazon Forecast do, which is different from anyone else in the, in the space? We try to, yes?
So if I use your tool, do you know what I learned from the tool?
So the question was, if I use your tool, do we know what you learn from the tool? No, we don't. If you're saying, is your model or is whatever you come up with yours and yours alone, it is. We don't know that, we don't look into that, and we don't share that with other customers. Okay, so it solves hard problems in forecasting. So fundamentally, the first thing it does is it learns relationships between multiple related time series. So what does that mean? It basically means that if you have, let's say, 100,000 products, or let's keep it simple. Let's say you had 1,000 products, right? And these products, some of them were coats, and some of them were, say, scarves, and some of them were boots. If you had the time series data for all of these 1,000 products, and if you fed that into the model or you fed that into Amazon Forecast, it it will learn that winter coats sell at the same time as winter boots. So it learns these relationships, and by learning those relationships, it can actually do better predictions. So, and where it really shines is when you have multiple related time series. As an example, all the products on a website, or all the routers on a particular network, or all the revenue from all the product lines that a particular organization is building. So a classic example of that would be if we wanted to use Amazon Forecast Inside to do AWS predictions of revenue for all our services, it would really work for that particular use case because these services are related. So they need to be multiple related time series. It incorporates external data. So with a little change in the API, with a single flag change, you can actually incorporate external data like the holidays database. You can also bring in your own database. So if you can bring in your own promotions database, which basically tells us when a particular promotion happened, you can incorporate that into Amazon Forecast as well. So that's something which is a little unique. It can generate forecasts for new items. So just like I showed you in that MQRNN example, we're able to forecast, provide forecasts for items which we don't have that much historical data about. And finally, it can predict spikes accurately. So again, the point there is that whenever there is a spike because of a holiday or because of any other external event, it's able to predict that compared to some of the other methods. So it's an automated time series forecasting platform. So what does that mean? Basically, what that means is it can forecast any time series. So it's not specific to a specific domain. It's pretty agnostic. As long as you have a time series, we can try to forecast that using Amazon Forecast. To that question of the data and your models, what it's really doing behind the scenes is it's taking your data and creating a deep learning model on the fly. Right? And that deep learning model is based solely on your data, and it's a custom model for you, and it's not shared with others. That's actually a pretty inventive thing. There's probably few or no other product except for maybe Amazon Personalize, which is a sister product for Amazon Forecast, which actually creates a custom model for you on the fly. And it's a process which we use inside called AutoML, which will help you create that model. Once that model is created, you can use our console to visualize forecasts. Obviously, you want to benchmark your numbers. You want to see if the forecast is good or bad. So you have a way to visualize that. And this last step is around exporting the forecasts into whatever business system that you have on the back end, so you can actually use those forecasts in some meaningful way. So as an example, if you're a retailer, or e-commerce vendor, or a manufacturer, you probably have Oracle and SAP for order management, inventory planning, or what have you. You want to be able to export that information back into these systems. And we provide an easy way for you to do that by basically allowing you to dump on a particular schedule the forecast to an S3 bucket. So all it's doing is on a particular schedule set by you, whether it is hourly, weekly, or daily, or monthly, it will generate the forecast and create a file for you to export into your system. So to the point of it being applicable across different domains, like I said, you can use any time series data with Amazon Forecast. We've made it slightly easier for you on some domains. So the first step really is trying to figure out which domain your use case fits into, right? And some of these are very obvious. If you're a retailer, your domain's probably retail. You want to do product demand forecasting, inventory planning, if you're a manufacturer, and so on. There's also, if your use case doesn't fit into any of the domains listed there, you can obviously pick custom. And really what the domain is doing is it is prescribing a schema for your data set. And that schema that is prescribed based on your data set is specific to that domain. So as an example, if you're doing retail, we need your historical sales data, right? Or if you're doing web traffic, we need your historical traffic data. So it's just giving you a simple schema which you need to comply by when you're creating your data set. And that's pretty much the first step. We need to get that data from any of your systems and create this data set so that Amazon Forecast can consume it. Once you've set that up, and that's pretty much all the heavy lifting there is, right? Because once we can get the data and once you have that in the format that we can actually consume, it can do the rest. So the first step is to set up your data pipelines. So with a couple of API calls, you can actually set up your data pipelines, which means that it can pick up the data from an S3 bucket on a regular basis. So you can dump it every day or week or what have you. It can pick it up, and it can clean the data. It can impute missing values. It can ensure to take out the bad data from it. So it does all of that automatically for you. So it sets up the data pipelines and does data cleaning. Once the data cleaning is done, you can choose to use any of the algorithms that are pre-built. You have two choices. You can choose a particular algorithm to train a model. So you can say, hey, I want to train a model based on MQRNN, or there's another deep learning algorithm called DeepAR, which is available. You can say, I want to train a model using DeepAR, or you can choose the AutoML option. What the AutoML option does is it actually trains a model per algorithm and chooses the right algorithm for you based on the shape and size of your data set. So choosing AutoML basically takes out the complexity of you having to choose the algorithm. And so if you're not one of those people who want to really tinker too much, I recommend choosing AutoML and letting Forecast make the decision on what is the right algorithm for your data. Once you've got your algorithm chosen, your model gets created. A model is called a predictor in the Amazon Forecast verbiage. So you've got a predictor created, and that predictor now needs to be evaluated. So any model is only as good as its accuracy metrics. So you want to compare accuracy metrics across predictors, right? Ideally, you would want to create a model, get its accuracy metrics. You might want to do multiple of these models and get accuracy metrics across these different models to see which one works better. Once you have the accuracy metrics and you're happy with these metrics, these are offline metrics which are computed based on your data. So what we do, again, in the back end is we automatically do a train test split. So we take some of your data and use that for training, and we leave the rest of the data for us to test. So that's how it compares the metrics. And based on those offline metrics, you can say, hey, this particular predictor works really well for me. I'm good to go. You can deploy your predictor. And what that means is, at that point, it's basically starting to generate forecasts for you. So once you hit an API, once you hit a button on the console, or you use an API and you hit deploy predictor, it goes off and runs inference on all of your time series and makes predictions and generates forecasts. So if you dive a little deeper, basically what we're talking about is pretty much 3 different steps. The first step is getting your historical data, and you could also use related data. So the only really required data set that we care about is your historical data set. If you have any related data, you should also give that to us just to make the forecast accuracy better. In case you're actually trying this out, I would strongly recommend the way to do this is to incrementally do it, meaning start with 1 data set and then add more data sets. Because if you start with 5 or 6 data sets, it can get very messy because you're having to clean and input all these data sets into Forecast. So I would strongly suggest starting with 1 data set, historical data set, and then adding things like metadata and related time series and so on. So once you add this data sets into Forecast, you then basically go off and create your customized forecasting model, right? And that, as I mentioned before, is usually a matter of a few API calls. Finally, when you're ready to export those forecasts, you have at least 2 choices. One, we have a REST API which you can call to get your forecasts. So if you have an application on the on the back end which calls out to us to get the forecast, you can use that REST API. It gives you the forecast information of a particular item in JSON format. Or you could dump the forecast in CSV format and pick it up and upload it into your order management or inventory management or any other backend system as you please. So you can choose the API or the file export option. And finally, you can also just visualize these forecasts. If the key use case is just getting insights from the forecast, if you just want to visualize it, you can do so as well. So there are 3 ways in which the generated forecast can actually be consumed. Make sense? Any questions? Okay. So the first step, like I said, data ingestion. There are 3 types of data sets. The target time series is the historical time series data. That's the only one which is required. The related time series. So this is an interesting data set, which if you have it, really improves forecast accuracy. This data set really is about the time series, which is related to the time series that you're predicting. So another classic example for that is, again, if you look at products, the things that are related to the sales demand or the demand of that product is price, right? So if you have a related time series, which basically tells us what the price of the product was on any particular day, we can use that information when generating the model. Same with web hits. If you can tell us exactly how much web traffic you got on the item detail page, on that particular page of that particular item on a daily basis, it gives us more information to do a better forecast. So the idea here is basically saying that any particular item which we are forecasting has variables which affect it, right? There are multiple variables which affect a particular, particular forecast of a particular item. So as an example, like I said, price or web hits, you can imagine weather being something which affects it. So all of these time series can be input as related time series. So you could create a related time series for the weather on any particular day and input that into Amazon Forecast as a related time series. In fact, we have a couple of customers who are doing that. Attributes of the item, such as category, genre, brand, that's the item metadata data set. So these 3 data sets come together, and we'll create the forecast for you. But as I said before, you can just start with the target time series and then add these other time series data with time. So the key thing I wanted to focus on after the data sets have been created, it's fairly easy to create that model, as I said, using a couple of APIs. But where people actually have questions is usually around our metrics. For every predictor or model that you create, and pretty much model and predictor are pretty much the same thing, we generate metrics for you. And these metrics are really accuracy metrics of that particular, of how that particular predictor is doing on your data set, on the test part of your data set, right? And unlike other services, we don't really just generate one number. Most services will generate a number called a point forecast. What we actually generate are what we call prediction intervals. And these are what are probabilistic forecasts. So as an example, there is something called a P90 forecast. A P90 forecast is basically the number, the predicted number, where we're 90% confident that the actual observed number is less than that predicted number. So think of it this way. If I'm selling coats again, and I want to be able to forecast how many coats I will sell in the next month, say on a particular day, Jan 30th, I can get my P90 number, and that will basically give me the high end of how many coats that I'm likely to sell. So the P90 is, there's a 90% probability that my actual number is going to be below that number. And the reason why that matters to me, say as Amazon or any other retailer, is that you really want to have enough stock to fulfill all your demand, right? Because there's no way you can get that point forecast. I mean, an algorithm might say, look, you're going to exactly sell 356 items on that particular day. As we all know, that doesn't seem intuitively right? Because 356 is likely to be not true. It might be, somewhere around that number. What happens if you sold 370? Suddenly, you are out of stock for those 14 items. So what we do is we look at the P90 number. So the P90 forecast gives you that upper bound. Now, if you really want to make absolutely sure you will never go out of stock, you can also look at the P99 number, right? That is the number at which there is 99% confidence that you're not going to, go out of stock. In this diagram, the very easy, simple way of conceptually thinking about this is think of it as a range. The black number is the real, actual time series number. The red is the range. The upper part of the range are the P90, P99 numbers. The lower part is the P10 number. So these are prediction intervals. The P10 is basically, hey, I have 10%. There is 10% confidence that the forecast is going to be about that number. So it's going to be kind of the lower bound in some ways. So we report, as part of the forecast service, we give you P90, P50, and P10. And that gives you kind of this range on which number to pick based on your business case. So if you just wanted to get, say, an approximate value of what we think will be the revenue in the future, you probably want to pick P50. If you want to be like confident and want to make sure that you're at the upper bound, you'll pick P90 and so on. And because we give you these forecasts at these different quantiles, what we compute, therefore, is quantile loss. Right? What that means is, what is the given a particular actual number, what is your loss compared to the actual number? Think of it as an error, right? The actual number is, say, 20, meaning that particular day we predicted like 25 for the number, and we actually hit and the actual number turned out to be 20. You've got a loss because you got it wrong by 5, right? So we will give you, the P90 loss, the P50 loss, as well as the P10 loss, and that's what you're going to be looking at. We also give you root mean square error, which is more of a traditional metric, but basically what you're looking at is some indication of how good or bad your forecast is based on how large your error is. Almost nothing comes to 0, right? It'll be very hard to get to 0 error. If you have a really predictable curve, something which is like a sine curve or something which is like just incrementally just going up, we might come to some small number in terms of error. But typically what we've seen in industry data sets is your error is going to be around 0.3 to 0.5 or 6, depending on how good or bad your data set is, right? So don't expect the forecast to be completely accurate in real-world data sets. But again, you want to use these forecasts in some smart way, and usually this level of error is acceptable for like things like ordering items or like inventory planning and so on. So you want to really look at these metrics across these various different predictors that you train, and the next step for you would be to deploy a predictor and generate forecasts. You can use a single API call to schedule forecasts, and it can be generated on a regular basis. So I myself have trained a couple of predictors. It hasn't taken me more than a day to do so, and I didn't write any code. So it doesn't really require any coding at all to go off and train a custom deep learning model based on your data. All you really need is that data set. To that point, we have a console, which is pretty intuitive, much like other AWS consoles. You're able to do a lot of things, which you can do with your API on the console as well. You can start with importing your data. You can train your predictors with one click, literally that orange button there, which trains predictors. And then you can look up forecasts.
I have a question.
Yes.
So if you're dealing with items that have different lead times, does that go into your model, or is that done in the other intelligence that your forecast is put in?
Right now, with different lead times, you'd have to like pick the the lowest lead time. It's dealt with in the backend systems is the short answer. So you'll have to pick a lead time which makes sense for you, so you can get as many forecasts as you can, and then you'll have to deal with it in the other system. So yeah, we don't have at the moment any kind of specialized domain specialized functionality right now. So it's basically just doing forecasting. So you can visualize the output of these predictors. You can get the P90, the P50, and so on, and the actual demand. The console is, while it's pretty basic, it's pretty useful in terms of like trying to figure out and do the smell test on how good your forecasts are. That's pretty much all I had for today. Happy to take questions, answer any issues, problems you have? Yes? Could you see the demo of a console? I didn't prepare a demo right now. It will take me a few minutes to bring it up. Huh? Okay. Is it okay if I have to look at John here? Are you okay? Well, I'll have to like that's okay? Okay. Fine. In the meantime, anyone else questions? Yes.
I'm wondering how this relates to the other deep learning platforms, or is it connected to that? I'm simply interested in how legislation impacts selling products or services. Is there any testing on that?
So how does this impact, the question was, how does this impact any other deep learning products that are platforms? So it's an AWS product, so it's built on some of our own platforms. So it's built on SageMaker. And in terms of legislation, are you saying something more around government regulation around that? So really, this is your data, and we are building a custom model on that. So unlike other kinds of models which you might want to use, which might have some regulatory implications, this doesn't. So it's just like using a tool,
I'm thinking
right?
if I take a new law that regulates that a company has to pay taxes where they didn't have to pay taxes before, if we can put it into the NLP engine, it could understand that, and then that could lead into a forecast where I could say, well, I know I'm not going to get, my tariff for China is higher this year than last year because of legislation, so you can predict that in your system.
Oh, wanting to predict legislation. Yes, of course. You could do all your predictions. I guess I misinterpreted the question. The question is, can you predict things like I have to pay taxes in China? Is that right? Yeah. I mean,
First interpreting the law by using NLP to interpret the language and make sense of it.
if you can interpret the language and make sense of it using an NLP engine and create a time series data from it, sure, you could do this.
I have a question.
Yes.
How do the AWS services in this area, machine learning, compare with GCP and what Azure offers?
Yeah. So we are actually in this particular area compared to our competitors. I would say because of the fact that we've spent so much time doing forecasting technology, we're ahead of the competition, specifically in terms of A, building custom deep learning models on the fly. B, having these algorithms which have been published, some of them, but also have been developed internally at Amazon. So we have a lot of forecasting algorithms and forecasting experience compared to I would say the other public cloud vendors.
Do you have any kind of white papers that you publish, just like in other industries, they create some kind of a comparison matrix or something that you can take inside?
We don't have a white paper right yet, but we're working on one so that you can use once we have it published. We do have some example data sets in our documentation that you can use as sample data sets to look at the forecast numbers and so on. We also have a sample notebook which you can run through with that sample data sets, but that's good feedback. We can work on a white paper.
Rest of the products, industry-wise, there's always a comparison data available. And it's always a challenge to decide which APIs to go with in your company. Right?
So the question is, there's a challenge to decide which APIs to go in with AWS or across different cloud vendors.
Because our strategy is, multi-public cloud support.
Sure.
GCP, I work for SAP.
Okay.
So whether to take an application on AWS or GCP or Azure or Alibaba,
Right.
we have a 4+1 strategy. How do we decide that, right?
How do we decide that? That's a good question. So, first you want to look at what this product suite that each of these vendors offer. They're not all the same, right? Some of the times it is. So then you'd have to actually do benchmarking and stuff, right? In this particular case, this is actually quite unique. Now, I'm not saying that they never will do anything like this, but this is unique in its API and features. But that said, if you're looking for benchmarks and numbers like that, we'll put that together in a white paper.
I think that would be useful because I think we have to make a call as executives, and once the direction gets set, then we stay on that course, right? But to come up with an answer itself is a very challenging task within the company.
I see.
Everybody's selling them their own service.
Right.
Unless there's a third party out there
Yeah.
which is comparing all three of them and then guiding us. And I haven't seen anything. So
Right. No, that's a good point. We'll create more material. What I would also do, regardless of what material we'd create, my strong recommendation is for you to benchmark and try it out yourself for your data sets. Machine learning is a very tricky field in the sense that different things will work for different data sets. Assuming that it isn't that much of an effort to try it out, right? For things like forecast and personalize, it hopefully isn't. It's not like you're expending multiple hours of any data scientist's time. But that said, the more information, the better.
yeah, but that's just one data point. We also want to understand the commitment of each company behind these initiatives going forward.
Got it. Yeah, that makes sense. as AWS, generally, the question was, what is the commitment for each of these initiatives going forward? At AWS, generally, we're committed to all our services that we launch. As you probably may know, if you have been with AWS, we don't tend to like give up on any service, right? We are committed to making that service successful. Like if you look at all our database services, we tend to be pretty like focused on making them successful, making them work with customers, making it work for different customer use cases. So I have some slightly bad news on the demo. I need a different VPN to connect into my demo console, so I can't actually show you the console demo right here. Probably have to go back, and it'll take me a few minutes to go into my bag and ruffle a few things there. So that said, if you want to apply for preview, you can do so right now, and we can whitelist you in either by tomorrow is our next wave, so either by tomorrow or by next Friday. We can try to whitelist you as soon as possible, so you can actually check out the console yourself.
How far into the future from the last historical data point for a time series? Is it reliably predict or forecast?
So the question is, how far into the future does Amazon forecast reliably predict? We recommend not predicting no more than 1/3 into the future. So let's say you had 100 data points in the past. We don't recommend you predict 200 data points in the future, because obviously it becomes less reliable with time. Typically, I would say about 35 to 40. Sure.
You had mentioned that forecast takes into consideration holidays and special unique events, seasonality. Does that apply across different countries or regions? So if you want to predict product demand in separate countries that have different holidays or different seasonal patterns, you mentioned you could include specific holidays for different regions, but the seasonality or other unique events, would you have to manually input that for that, or does the model handle different countries or geographic regions?
Yeah. So the question is, how does the model handle seasonality and holidays across different regions? So the good news is we do have a holidays database built in. It's a global holidays database, so you can set in the API which country you're predicting for, and it'll pick up the right holidays based on that country. And when it comes to promotions and stuff like that, you do on events. So let's say you have specific events happening in a specific country. We don't have knowledge of that, so you would have to input that as a different time series data set. Any more questions? Yes?
Can you talk a little bit more about loading up the data process, kind of what that looks like, and how you figure out what the data means, just based on schema, or you actually scanning it to figure out different metrics about it, and then do you use that to build different features kind of behind the scenes?
Yeah. So the question is, how do we figure out the data cleaning and the data exploration and the featureization process? So if you look at the documentation right now, we recommend a specific schema, like I mentioned. So what we're looking for is data sets which conform to the schema. So once you upload, so take the simplest one, because that's easy to explain when I give you an example. The simplest one is timestamp, item ID, demand, right? So that would just basically say, for each day, let's assume that we want daily intervals. So each day you'll have a row, and for each and there is a row per for each item and day there is a row. So let's assume that there is like a quote. So and the quote has an ID 20. So 20 and timestamp and the sale on that day. So if you give us the data in that tabular format, we pretty much take that. That is the minimum required. What we do after that is we look at the data set and say, hey, let's look at how big this is. How many rows did the customer input? How many items did it have? How good is the data? Meaning, if it's a fast-moving data set, and what we mean by fast-moving is, if there is a lot of sales, that means we have a lot of signal. So if it's fast-moving, the predictions can tend to be more accurate. If it's slow-moving, predictions can get like iffy because there is not that much of signal, right? So based on whether it's fast-moving or slow-moving, based on how much historical data we have, the more historical data you give us, the better. At some point, it doesn't make we don't want like 1 billion data points in the past, right? But if you at least give us a few thousand, the model will learn better. So how much historical data we've got? Based on that, we basically then decide how to featureize, and and the AutoML will then run across these different algorithms. That said, we do have guidance in our documentation on which algorithm works for what types of data sets. So there are a few algorithms which work better for items which are slower moving, a couple of algorithms which work better if you have lots of cold start items. So if you have items where you don't have that much history, there are a few algorithms that work better for those. There's obviously a few algorithms which work, and most algorithms actually do, when you have a lot of data and it is fast moving. Yes?
You mentioned that forecast becomes more powerful when you have multiple kind of related time series data. Do you find that in most use cases it's used that people always do use related time series to increase the predictive power? Or is it kind of more on a case-by-case basis? Like with some models it doesn't work as well, or your distributions?
Right. So the question is, how much does related time series impact model accuracy? And really, that depends on how much related time series varies over time. So for example, if your related time series was price, and if price wasn't varying at all, right, then it doesn't really matter that much for model accuracy. So and also how related are the two variables, meaning maybe you came up with weather, and then weather maybe was not a correlated variable whatsoever, and so it won't matter at all. So it's about picking the right related time series and also looking at how much variation is in that, right? Based on that, it really depends. The model accuracy will change dramatically or not at all. And part of that is just having, depending on your use case, you probably will have a really good intuition on what these related variables are. In a lot of cases, it's also hard to get the data, right? You could say, hey, you know what? I think weather at exactly this moment is what's really important. It's probably not that easy to pull that data, so you have to go with historical time series data, which is okay. So if you don't have related time series data, it doesn't mean that you can't use forecast, or it doesn't mean that the accuracy is going to be terrible. You are just improving accuracy if you have that. Oh, okay. So thank you. And I'm obviously available here for a few minutes if you have any questions, if you have any more questions for me. And like I said, hopefully you guys will try out Amazon Forecast.